Yeah, okay. I think we can start. Hello everyone. My name is Michał Trojanowski. I'm joined here by my colleague Gary Archer. We're product marketing engineers at Curity, where part of our day job is sharing our knowledge on API security related and identity related stuff. And whenever we think about identity, we usually think about humans. When someone logs into our website, we think that it's a human user, and we want the identity of that user to properly secure our website. But the truth is, in today's distributed world, we've more and more deal with identities which are not connected to users, either because there is no user involved. Maybe we have a B2B connection, a company that just sends requests to an API of another company, and we have no users, or the non-human identities are used to even give better security to connections to APIs where users are involved. And this is what we want to talk today about. So non-human identities that allow you to create more secure solutions. So Gary, do you want to give us a bit overview of what NHIs are?
Sure, thanks, Michał. When you reason about securing workloads, we sort of recommend that you start with the big picture, if you like. So there's many different workloads. Often the most important ones are the ones that deal with your business data, and business data is exposed by APIs. Typically, you have a backend. Like if you look at the box on the right here, there's a number of backend components like an API gateway, observability systems, continuous delivery systems, and so on. And there's various places where you often need to secure a connection, and some of the older practices like using API keys, etc., maybe open up threats against your systems. So the idea behind non-human identities is to strengthen some of these connections. And there's also workloads that run in the outside world. So not all workloads run within a backend. You've probably heard the word workload in platforms like Kubernetes quite a lot, but they're not the only workloads that exist. For example, you have web and mobile apps. As Michał was saying, you might have an API connection from a B2B, a business partner that's calling you from their own APIs, or you may even need to support Internet of Things devices like, cars, televisions, various devices that might need to call APIs and do secure operations. So we think that terms like non-human identities sometimes make people think there's a completely new solution, but often it sort of comes down to your requirements. So if we look at uh, the next page, so what we're trying to do in this webinar is to get you to understand the big picture of the problems you need to solve. And usually when you're dealing with business data, the two main requirements are authentication and authorization. And we'll show how non-human identities give you better options in the authentication space. And we will also talk about how to deal with the authorization requirement as well. And so, any connection these days that uses business data should be secured. And exactly how you do that may depend on where the workload runs. So if it's running on a mobile device, that's a bit different to your backend components, for example. So one thing that is quite new is the whole world of workload identities and platforms that enable you to use new types of secure communication between backend components. So Michał, you were going to give us a bit of an overview of the main behaviors. And I think what we'd like to do in this section is to sort of tell you what workload identities are good for and call out I suppose, the good points about them.
Yeah, yeah. So um, let's start with what is a workload identity, or even what is a workload, right? Because we started to use that name here. And in the world of backend, when we think about a workload, that's the clustered instance of a software component. So if you think, for example, on a platform like Kubernetes, if you have a microservice or a database that you deploy to that platform and it's deployed to a number of different pods and a number of different containers, all these pods and all these containers, they form a workload. So this is the workload. It might be also a service that you deploy to different virtual machines, for example. But as long as we're talking about like the same instance of a service of a program running somewhere, we think of it as the same workload, and that workload will get an identity which is represented by a unique identifier. And here we have a bit of similarity to the user world. So when you think about the user, the user identity is represented by a user ID, right? So a unique identifier somewhere in the system, which is then complemented by some attributes about the user. And here it's pretty much the same. So you have a workload that has an identity, so a unique identifier, and then you have a set of attributes about the workload that allow you to identify it and exchange that identity between other workloads. So if we go to the next slide,
Yeah.
uh, the workload identity is like the abstract concept, and then it has to be represented by something more concrete, and that something more concrete is workload credential. And again, we have similarity to that user world, where when a user comes into a website, they authenticate, they log in, and so the server asserts the identity of the user, and then it presents some kind of credentials to the system, for example, a cookie or an access token, something like that. And here it's pretty much the same. When a workload starts on a platform, the platform has to assert the identity of the workload, and then it will issue a credential, so a document that represents that identity. It will use strong asymmetric cryptography, so we're sure about the security of the credential, and the platform will also perform some attestation checks, so that it knows that it issues the correct credential to the correct identity. But I'll talk a bit more about it in a second. And what is important about the credentials is that they are. I think we're back on the previous
Okay.
slide.
Sorry.
Yeah, that's one. Yeah, they are short-lived. So they are short-lived, and they are automatically managed by the platform. So whenever a workload starts, it gets a credential which will be valid for something like an hour, and then the platform will renew it automatically if it's needed, right? If the workload is still there. So it gives us that better security, because we're not dealing with some static credentials which are very long-lived and which are problematic when they leak somewhere, but we have short-lived credentials which are usually much better. And once the platform issues that credential, the workload will have to start somewhere. And again, we have that similarity to the usual application or a website, that whenever it gets tokens or cookies, it has to store them somewhere. So here, a workload will like store it on a disk or in memory, and then can use it in different use cases, like proving can prove the ownership of the credential to other workloads, and
I think because
things like that.
yeah, a lot of these types of solutions have existed for a long time, right? Client certificates and things. But if you have to manage them yourselves for every component, it gets complicated, doesn't it? From a reliability viewpoint and dealing with all of the renewals and stuff. So what's great about the platforms that provide this, which um, obviously it's Kubernetes, there's cloud systems like AWS environments can do this type of
Yeah,
potentially, then you don't have to deal with that manageability because you're running on the platform already. Then hopefully it deals with this stuff for you, and you can focus on just the credential is always there and always up to date.
hmm yeah. I think we mentioned that on the. If we go to the next slide. Exactly. So there are different technologies that you can use for those credential documents, and this will depend on the platform that you actually use on your backend. So in plain Kubernetes, you would use something called service account tokens, which are JOTs, JSON Web Tokens. But if you're running on AWS or Azure or Google, they have their own technologies that are used for workload credentials. And there's also a standard called SPIFFE, and Spire is the implementation of the standard, which gives you interoperable credentials for workloads. They are either in the form of a JOT or an X509 certificate, and so what this gives you is that you get workload credentials that can be shared between different providers, between different platforms. So you're not tied to the identity and the credential that is issued by AWS, but you can use that and be able to identify your workload or authenticate your workload at an Azure cloud, for example. So that's nice part about Spiffy Inspire.
And I think these days some organizations are doing, some reverting to on-premise deployments and things, and the Spire type of system enables you to use workload credentials on-premise if you need to. So, uh, and yeah, so we
Yeah.
think let's
Let's have a look at how the process of issuing looks like. So when the workload first appears, it will send a request credential to the platform to so that the platform can issue the credential. And what the platform then does, it has to attest the workload, and you can set some policies that will allow the platform to identify the workload correctly. Things like checking whether it's the code that the platform expects to be run by this workload, whether the environment is what it expects. So maybe like version of some drivers or version of the JVM which is used. There are many things that the platform can check to verify whether that's actually the workload that it should attest, that it tries to identify. And once it does that, it will issue the credential document directly to the workload, like save it somewhere on a disk or on a volume, so that the workload has access to that credential and can then use it in different use cases.
then
We have a question here. Is it possible to exchange workload credentials for tokens, for access tokens like these created by Curity, for example? And we're actually gonna talk about it in a second. So,
we have
uh,
a demo that does exactly that. So
yeah. So it's a very, very, very good question.
Mhm.
Once the workload has the credential, why is it useful? What can we do with it, right? And the thing that probably first comes to mind is that workloads can allow or deny access to each other. So when you have different services, like service A talks to service B in your backend, it can verify that the service B can check that only service A can actually send requests to my endpoints. But you can also apply some, like level of access or policies to that, where service B can say, okay, service A can actually get data from my endpoints, but only service C is allowed to write data. And maybe even service C is not identified just by the name of the service, but maybe that's a group of services, like some administration services are allowed to write data to service B. So it can, using the identity and the attributes that are connected to the identity, it can then perform some authorization decisions whether that service is actually allowed to perform some kind of actions, or whether I should deny access at all. Just deny access. And service meshes, it's also a popular use case for workload credentials, where the service mesh can use that to encrypt connections between services. So it can upgrade connections from a plain HTTP connection to a TLS or an MTLS connection, which is even preferable, where both parties can authenticate and verify the identity. So every service is now not only have encrypted connection, but it also knows what other service it is actually talking to. And what is a nice use case is that workload credentials, as we mentioned, are short-lived, so they can replace static things like passwords or API keys, because they have some security problems. As we know, they're simple to use, but if an API key is leaked somewhere, then it's a problem to rotate the key. It's a problem that someone can easily break into your API. And the workload credentials give you much better and much more secure solution for that. And I think Gary maybe you can tell us a bit more how these strong credentials are used to replace those static ones.
So yeah, I think there's various places where API keys and passwords have often been used in backend systems. Maybe an API key or a database password uh, provides access to your database. But the problem with these types of credentials is they're often quite difficult to change because you have to change two components at the same time with zero downtime. And that's a bit of a problem, deployment problem. And obviously, if someone was to intercept these values, for example, they're sent in every request between components. So the secret is revealed every time you make a connection, potentially, if someone can eavesdrop and capture the API key or the password. And often then as I say, these credentials are not renewed very often, which makes them a security vulnerability. If someone was to misuse them, like a rogue employee or an attacker of some kind, then you maybe wouldn't know that they were abusing the system for some time, and therefore strong credentials can mitigate that kind of risks. And there are two main types, and we want to Miha's mentioned them already, JOTS and X509, but let's take a slightly closer look at how they work. So you have a platform such as Kubernetes, and in step one here, it issues a JOT credential. Um, on Kubernetes, this is a service account token, and you can configure its lifetime. As Miha said, it may only last for an hour or so, and then the platform will automatically renew it before it expires. When workload A wants to prove its identity to another trusted workload like workload B, it can send a JOT credential. The platform also provides a mechanism for recipients like workload B to verify the JOT and make sure it hasn't been tampered with and that it has the expected identity. So essentially, workload B can use a library and write a few lines of code that downloads the public key from a JSON web key set and verify the credential. So the client assertion flow is quite easy to use. It improves upon passwords because even if a JOT credential is intercepted somehow, it soon expires, and therefore an attacker would have to, get hold of another one. So therefore, you have that guarantee that long-lived attacks are prevented. And the mechanism is fairly simple. It's a one-way flow. The service verifies the client's identity. But what's interesting is how do you combine this authentication with authorization? And usually authorization is the harder part. So in this diagram, workload B would need to apply a policy to say what workload A can do. So when it comes to APIs, we have a particular recommendation around authorization that Miha will speak about later on. So that's the client assertion flow. So for example, in Kubernetes, you can use this without any extra infrastructure, and some cloud platforms may allow you to do this as well. And the other one is the X509 flow, which works similarly. The platform issues these certificate files, basically documents that can be stored in each workload. Service meshes use this approach to, and it's standard kind of mutual TLS really, where there's a sort of handshake and they exchange public keys, etc., and verify each other's expected credentials using, X509 certificate technology, which has been around for a long time. But what's
Mm.
new is that a platform or a subsystem such as a service mesh can issue these X509 identities and keep them up to date for many workloads so that you don't have to do that manually. And it also gives you like request confidentiality inside the cluster, like internal SSL. So a lot of people run service meshes for that kind of reason. So to summarize, X509 gives you a two-way flow where the service and client authenticate each other. You use encrypted channels to keep the data secure for internal requests. And the workloads receive basically a bunch of certificate files. So next we have our first demo, and we're going to demonstrate uh, a backend component like an API, making a connection to a database using X509 credentials. And as much as anything, we want to show you what these files look like and how an API could connect to a database in a passwordless manner. So Michal and myself, we recently co-authored a book all about combining authentication and authorization. And in that book, we have a GitHub repository that has an example deployment that uses workload identities. So we thought it would be a good thing to show in this webinar, because any of you after the webinar can go and run the deployment and see some workload identities in action. So let's go and find a browser. Oops, lose my email stuff. So if you go to github.com Curity.io, there's a bunch of GitHub repositories here, and the one that we produced for the book is called this one here, Cloud Native Oath Security Examples, and we're going to focus on Chapter 10, which has an example deployment that uses Spiffy and Spire. It's a reasonably complex deployment, but it allows you to see some workload identities in action. So you could just browse this to understand the roles of these components. So what we're going to show in this first demo is just an API that connects to a database using workload identities. And in this DB client folder, I'm not going to go through all of it, but essentially what we're going to do is we're going to get some X509 certificate files from disks that the platform has issued. And then the API is going to connect to a Postgres database using a connection string that doesn't have any passwords in it. And some of you may have been running this type of deployment before, but what's good about the workload identities is the improved manageability of it and the fact that the database credentials are kept short-lived. So what I'm going to do is I'm going to copy some commands that enable me to get a shell to some remote containers. So I've basically got a deployment running here on my computer. So what this does is this deployment in Chapter 10, if you were to run all of the scripts, you actually get a bunch of containers in a Kubernetes cluster, and you can run all this stuff on a local computer. If I run those commands, I get a shell to within a client container, and this is just a Linux workload. And what's interesting is that the platform has issued a bunch of workload credential documents here. It's worth pointing out that there are some solutions that store these in memory, and some of them store them in folders on. Probably it's more common to store them in a folder within the workload. So because this is a Spiffy and Spire based deployment, these are called SVIDs, Spiffy verifiable identity documents. But these ones here are just X509 certificates, basically. So it's a certificate and key. And there's also some job workload identities here that can be used in client assertion flows. So quite an interesting thing is to look at these in decoders, etc., and view the credentials. I'm just going to demo the passwordless database connection by copying this text. And there you go. So I'm connected to the database now. I could select data if I wanted to and interact with the database. And obviously that's more secure if the database contains business data than, using a fixed password, which someone might misuse. Um, so that could be a,
So the yeah, just maybe a quick explanation that the database is configured to know which SVIDs it's allowed
yeah.
to accept, right? So the
And
database know how to verify the certificate and allow only connections with a valid certificate from a valid workload.
absolutely, yeah. But one thing to understand about workload identities is they typically have a bit of a technical identifier. And when you interact with a system like a database server, the database server has its own way of identifying uh, callers. And for example, in Postgres, you have a database user. So here the certificate is configured with the name of a database user, DB client, and the Postgres server would apply its policy to DB client, such as only allowing it to connect to a particular database or something like that. So there's always authentication and authorization combined. But this first demo of workload identities at least shows that you can go passwordless, etc. Um, so this is using, as I say, this is using Spiffy and Spy, which at the moment means you have to deploy a new subsystem, such as a service mesh or the Spy system itself. Um, but we think this type of system is going to become more common, easier to manage, and so on, as and all of the providers seem to be doing it these days. So that seems to be the direction of travel. So hopefully that made a little bit of sense that, the platform issues the credentials and it enables passwordless connections between some kind of backend client process and a server process. And as we saw there's usually a mapping from the workload's technical identifier to the identifier that the service expects, such as a database user ID. So that's workload identities. Next, we're going to switch a bit more to authorization in APIs because, as Mihal will point out, workload identities don't provide, well, non-human identities don't provide a full authorization solution, but you can combine strong authentication with traditional standards for authorization, and Mihal is going to speak more about that.
Yeah, exactly. So when we think about APIs, and APIs are about the business data, they're the resource server where you get the business data from. And workload identities are give a good level of security, but it's not the level of security required by APIs. So if we go to the next slide. Um, a, mm, Whenever we want some data from an API, that API needs to perform authorization. And if that API is called by something like a B2B partner, then the identity of the calling API or calling backend, that's usually enough to perform some authorization. So we know that, for example, we're allowed this company to actually call our API and get some information about our, I don't know, stock or prices or something like that. But very often we will have data that is connected to a user. And then workload identities are simply not enough because to make that perform that authorization, we need also information about the user. So, with workload identities, you're able to say that service A is able to connect to get data from service B, but not from service C. But someone can send a request to service A. A user one sends a request to service A and asks for data from user two. So now both services, service A and service B, they know that they can talk to each other and return some data, but they also have to be able to decide whether that user one is actually able to get that data. And it turns out it's really common problem and common issue. OSP, they um, they publish a list of top APIs vulnerabilities, and for the last 6 years, or so, if I remember correctly. I think the first one was published in 2019. The broken authorization is still number one problem for APIs. So still we have an issue in APIs to do it correctly, to correctly verify that okay, this user is able to actually get this data. So we can move on to the next slide.
I think that's a good point,
Yeah.
Mia. It's what we said at the start of the webinar about seeing the big picture and having an architecture that accounts for things outside the cluster, like users, in addition to the strong connection. Because I think where a lot of people go wrong is they use something like a service mesh and it gives them mutual TLS, and they think that gives them a full security solution, but their authorization goes on afterwards. So in those connections I just showed you, like workload A calling workload B, the workload credential alone is not enough because it doesn't contain the right data for authorization. For example, it can never contain a user ID or any other runtime claims like those provided by third-party systems, etc., that are sometimes needed.
Yeah, and this is where auth comes in. So auth 2.0 gives you that framework for that business level authorization, business level protection. So in a mature API, you would use token-based, what we call token-based security. So use access tokens that contain claims about the user or also about the system or context. So pieces of information that then the API is able to use to properly authorize requests in that context for that user. So access token gives you that business level of authorization that we just mentioned, right? This is the data that you need to verify those requests, authorize those requests, and check whether the API should return that data. And these two worlds can work together. So on one level, you have that access tokens, but by using workload credentials and by using workload identities, you can harden the security of those access tokens. Because in order to get an access token, a client needs to connect to the authorization server. And what we usually do these days is we provide some kind of password to the client, and so that client can authenticate at the server and get a set of access tokens. But with workload credentials, you can then switch to that hardened credentials, as Gary showed, where the workload uses that dynamic certificate or JOT to authenticate itself at the authorization server. What is more, with these type of credentials, the authorization server is also able to return tokens which are constrained to that concrete workload. So what we call sender constraint access tokens. So, for example, you have a service in a backend that is processing requests, and that service gets an access token from an external client. It can then use the workload credentials to connect to the authorization server, authenticate, exchange the token for a different access token that is now tied to that concrete workload and that concrete backend service. And now, if anyone manages to steal this token in the infrastructure, they won't be able to use it because only that workload, only that service is now able to use that access token internally. So you applied workload credential security to that business level security to give you overall a much more secure solution in a zero trust manner.
Yeah. And one interesting point there, Michal, is a lot of people who've used OAuth, they're maybe only familiar with using client secrets, but for a long time, OAuth standards have supported both client assertions that we showed earlier and also X509 credentials. So, as we're going to show a little bit later on, you don't have to use client secrets. One thing that's prevented, using stronger OAuth client credentials in the past is the manageability burden of having to deal with keys and certificates and stuff. And as Michal says, by combining these modern platforms that issue workload credentials with OAuth support for these strong credentials, you can get both strong authentication and also, of course, the correct authorization as well.
Mhm.
Really, you need both. That's the key point. So, as Michal said, we can join these two worlds. So I'm going to show you another demo that's included in the same deployment. And this is exactly the question that that was asked earlier about how do you use these workload credentials. So this is something you can do in any Kubernetes deployment if the authorization server supports it. So again, in the example repository here, there's a folder called auth client, and what we're going to do is we're going to make a connection to this pod. But when you configure a workload in Kubernetes, you can request a service account token here, and then send that to the authorization server as a strong credential. So what I'm going to do is to make a connection to this this workload, and then the Kubernetes platform puts this service account token there on disk. So unlike Spiffy and Spy, you don't need to deploy an extra subsystem. And you then in the service account token that's issued is this subject claim. And as you can see, that's a long technical identifier. So what the authorization server can do is to enable you to map that to an existing OAuth client ID. So we're just going to show that in action. If I go back to my shell here, I'm now going to get a connection to a different container. There's a service account token is issued to disk by the platform. And again, this is automatically renewed. This is just a jot. And then, I'm sure many of you are familiar with connecting to the token endpoint of an authorization server and sending a client secret. And this just does the equivalent thing, but the only difference are these two parameters here, that the client assertion is just loaded from disk and sent. So if you're already running in Kubernetes, this type of system where you upgrade from client secrets to client assertions should be minimal effort. So I'm just going to log in and get a token here. There you go. I've got an access token. This could be a jot if you wanted to. We've just used the default of a opaque token in this case. But as you can see, we've exchanged the workload credential, which enables strong authentication, for an access token that enables the correct authorization. So therefore, you can run the two worlds together and meet all of your requirements, hopefully, or all of the main security requirements for APIs. Do we have any questions at this point, Michal, or shall we?
I think we can continue.
Okay. So so far we've shown credentials managed by the platform like Kubernetes or Spiffy and Spire or service meshes, or maybe even Microsoft Azure or AWS. But there's also the outside world, and ideally, you want to use these strong credentials from the outside world as well as within your backend platform. And in some cases, you may be able to do that. So, for example, modern mobile devices support something called application attestation, which we're going to look at shortly. And this enables the mobile clients to get a strong client assertion that it can use to authenticate itself. It's a little bit different in web clients. There's kind of a concept of a workload identity, but it's not really verifiable. Michal will talk about that a little bit later on. And Internet of Things clients sometimes, it depends on the exact use case, but in some cases you may run a subsystem that provisions each device with a distinct client certificate, for example, or certain other cases might use JOTs instead. So the flows we showed earlier might be usable in IoT scenarios as well. But let's have a look at the mobile case. So some of you may be familiar with mobile attestation, but essentially modern devices have an attestation system. And typically the way you would use it is to use a system like Google Play Integrity or Apple App Attest. and these involve like a service that Google or Apple provide, and also an SDK that you run within your app. And that service gives you a challenge which you send to the attestation system, or the SDK does. You get a signature, you send it up to the attestation service, and the data that you send up to the attestation service identifies the app in a way that prevents impersonation. So um, the end result of all of this in step 5 here is that the application receives an attestation jot, which is a bit similar to the client assertion flow we showed earlier. So the jot that the application receives can then be sent to other backend systems as a kind of credential.
Yeah, and I would say the attestation is a bit similar to what the platform does for workloads, right? So it will check whether the code is okay and whether the environment is okay. So if it's a jailbroken device, for example, or not, right?
Absolutely, yeah. It's the same concept, isn't it? It's rather than workload attestation, it's like a application attestation within the mobile environment. But um, these kind of concepts are showing themselves in various systems, like we say, mobile
Mhm.
backend platforms, IoT, etc. So, um, so what's interesting about the mobile attestation flow for mobile apps is that traditionally mobile apps are public clients, because you can't use a client secret on a mobile app, because um, it would be easy for an attacker to work out what that was and to get its own tokens potentially. But um, with attestation, you actually get something that serves as a kind of client credential, a sort of client assertion like credential that potentially, depending on whether the authorization server supports it, you could send that along with token requests and only issue tokens to the mobile app if it had a valid attestation jot. So let's look at an example payload. There could be a few different formats of these depending on the system. This particular one, what's important about it is that the package name is in effect the workload identity for this type of use case. So io.curity.demo app. What an attestation does is that only the app itself can uh, get a signature with its own package name. So a malicious app that a third party um, from a third party, or any other app couldn't get an attestation drop with the same package name. The system provides that guarantee. So therefore, this is very similar to the uh, jot assertions, very similar conceptually to a service account token. Maybe I could
Yeah,
say a
but
few words about the difference for web clients, because
yeah, it is a bit different, right, with web clients, and it's a bit more complicated because web clients are not able to hold any secrets, and it's not there are no such systems or that we have in mobile devices currently. So if you run in SPA in a browser, you're not able to put a secret securely, so that no one is able to get to that secret. And current best practice for web clients is to use some kind of backend for front-end component that will manage all the secrets for you. So it will manage any workload identity, and it will also manage any tokens or cookies that are issued to the app, and that component will communicate with the web client only through cookies, through secure HTTP only, same site strict cookies, which gives you a pretty good level of security against some attacks on web clients.
well,
Mm,
I always think of, I think of the origin header as being a bit like a workload identity, because within the browser, you can't, a malicious site cannot send a different origin header or whatever, but that's only limited to the browser itself. There's no guarantees against, anyone can craft an HTTP request and put an origin header in there.
exactly. Yeah.
So, the guarantees are not as strong, are they,
Yeah.
Michal, as for
And it's as long as you don't install any dubious plugins in your browser, right? Because the browser normally would protect the origin header, but as long as you don't have any men in the browser
yes.
that can perform some kind of attacks. So yeah, that's true. As you say with the origin header.
Cool. Let's move on then.
Yeah. To sum up, so we hope that what we showed you here today is are technologies that will allow you to eventually create more secure systems, more secure APIs, and actually more secure flows end to end. So from the client through APIs, through gateways to any backend components, so that. So that you get more secure and zero trust solutions in the backend as well.
Yeah, and I would
Mm,
always start with authorization, though, Michal, because I think that's the deeper requirement. And, you know, I, as I said earlier, I think sometimes you hear vendors or whatever talk about, use mutual TLS and everything's secure, but it's still easy for an API to return the wrong data, isn't it? So the
hmm.
authorization is where it tends to go wrong. Right? And
Yeah, I would.
sometimes
Yeah. Mm?
sometimes workload credentials can give you, non-human identities, and the stronger credentials can give you a false sense of security. So probably the key thing we'd like you to understand is that uh, you sort of need to blend solutions for strong authentication with the correct authorization as well.
Yeah, I think these are some different levels of security and different problems that are solved. And we have to remember that message encryption is not solving authorization, right? So it's important from a security point of view, but it doesn't solve authorization. And it's important to remember to combine all the tools. If you just switch to the next slide for a second. Um, where I think it's important to combine all the tools that you have to create more secure solutions. So, as you say, think about the authorization, think about protecting APIs, protecting the data with tokens, but using workload identities as a hardened version of security for your clients, for your backend clients, backend systems, to create zero trust connections in the on the backend side, but also using strong security on the client side wherever possible, right? So if it's not possible in the browser, we can use backend for front-end components or use client attestation in mobile world if we have mobile clients. And staying up to date with the best practices is always, of course, good something good to remember. OWASP publishes information on some best practices that you should use, OAuth groups or OpenID. They publish some best practices from time to time as well, so it's always good to be up to date with that.
There's even a working group, isn't there, Mia, called WIMSI, I forget,
Whimsy.
Workload Identity in Multi-System Environments or something. It talks all about, combining different types of tokens and credentials. So
Yeah, exactly. Yeah, there's still work in progress on the best practices documents there, but it's definitely worth keeping an eye on what that group does.
yes. And
So, more questions at this point?
and
We don't have any here in the Q&A.
there is one that I've seen asked before in discussion groups and things, and while we're waiting for things, but it's and this was if I go back here, it's this kind of thing here that I've seen people, with APIs or whatever, and they've got two APIs maybe, and workload, and they're using the drop credentials directly, um, and they ask, why do I also need the access token? And probably the key thing there, I think, is that the job credential doesn't have the right data, doesn't have the right data for authorization. So in some use cases, just a simple backend to backend authorization, this can work okay, but it just doesn't scale properly. And when you've got, you need to bring in the outside world and other things, then you get a very fragmented architecture. So what OAuth and if you use OAuth and workload, I'm sorry, non-human identities, the way we're saying in this webinar, you get this consolidated architecture. So APIs don't do one thing for one client and one thing for another client. The API authorization is uniform across all clients and things. And because, in a simple case, you might try to send a job credential and define a policy here, but it just wouldn't scale to, user scenarios and those types of things where you have deeper requirements around,
Hmm.
privacy, etc. So I think that's a common misunderstanding. Just because something's a JOT doesn't make it suitable for authorization. It's really what's essential is to do API security properly, the contents of the JOT, uh, if APIs use a JOT access token for authorization, they can get all of the most important authorization values there, like user IDs, tenant IDs, etc., roles, whatever they need. Um, and those claims in the access token can come from various systems, like external identity providers and so on and so on. So that's really what OAuth gives you is that control over the access token payload that sets up authorization.
Hmm.
Okay.
Yeah. Yeah, we have one more question. Can you use workload identities for backend to backend authentication to third-party API deployed by other company? Mm,
Usually not, I would say, because it's kind of like in these things are designed for one backend system at a time, and what OAuth enables you to do is to uh, connect these systems. But it's always true that each system has its own source of trust, right? And how that
mm,
so for example, if you're using OAuth, the authorization server issues the access tokens for your organization, and a different organization might work differently. They might have their own authorization server. So you always need to follow the organization's policy. And, you know, I think each
hmm.
organization does that differently.
Yeah, yeah, exactly. It comes down to trust, as you say.
Yeah.
If the I don't think it's being done like that, but if that third party company's platform or authorization server trusts your Kubernetes, your platform, then you are able to do it, right?
Yeah.
Because that platform can verify your identities. But I think more common scenario would be to have that third party trust, for example, your authorization server, so some kind of federation. So your workload would exchange the identity for an access token at your authorization server and then use it to again exchange that for an access token for the third party. And that third party knows that it trusts those access tokens because there's a federation set up between those two services, these two authorization servers. So I think it would rather work that way.
Yeah. And so it's the same two patterns, though, isn't it, Miyako? So in these like cross-organization use cases, you can use client assertions X509. They're still the standard solutions for strong security. And it's just a case of how you configure the uh, issuers and things, isn't it? The root authorities, etc.
Mhm.
So
Yeah, okay. Gary mentioned that before, that recently we co-authored a book together with Judith, our other colleague from Curity. If you've scanned that link, you can download the copy for free for a couple of months. Curity provides free access to the book, but it's also available on O'Reilly platform, or if you prefer physical versions, it's also available too for purchase. And there are also links to the repository that Gary used for the demos. So if you want to play around with the system, see how it works, what components are used there, I can take a look at that, and you can run it yourself as well. So um,
Yep. And so the book's all about combining, you know, it's primarily a book about authorization, but it also has quite a bit of information on non-human identities and these concepts of, attestation and so on. So um, if you're interested in more detail, you can read about how to combine authentication and authorization in this book.
Yeah, and actually, we'll have another webinar coming on June 24th, where Gary, myself, and Judith will be joined by Bill from Nordic APIs, where we talk a bit more about the book itself, what's in it, and what can you learn from it. So we'll have a like a fireside chat thing on June 24th. And I think the link to the webinar should be already live on our website, so you can check that out. Okay, thanks everyone for listening.
Great. Thanks all.